So let us look into a general structure of a communication systems. We are going to start with the source. So this source could be a voice data which is analog, or it could be a data which is digital, such as if you're writing on the keyboard or you're sending an SMS. So this information is then sent to a transmitter. The transmitter consists of several blocks. The terminal end of these blocks include a modulator, and for that we have the analog modulation, which includes all the schemes in AM as well as the schemes for frequency modulation FM or PM. And similarly for digital modulation, you could have QPSK or QAM. Preceding that block is a channel encoder. So what it does is it looks into a channel which is impaired by noise, and it would add useful redundancy in the data. So for example, if you are sending a message of 3 bits, so the channel encoder, what it does is it would look into the channel environment, and instead of sending 3 bits, it may send 4 bits, whereas the fourth bit could be a parity bit. Before that, we have a source encoder. While the channel encoder induces useful redundancy in the data, the source encoder rejects undesired redundancy in the source, whether in the text message, in a picture, or in a audio file. This has something similar to what you observe when you compress your file by using a WinZip or another software. And preceding this block is a formatter. The formatter is a block that we would consider next. Now moving on, the propagated signal is then received at the receiver end, and the receiver also constitute of all these blocks but in the reverse order. So what it would do is it would demodulate first. So this is a reverse process of modulation done previously. Next it would use a channel decoder, which would be in sync with the channel encoder. So the channel decoder would make use of the useful redundancy induced by channel encoder. It would estimate the data over here and transmit it over here to the source decoder. Source encoder removed the redundancy in original data, so source decoder would return back the redundancy. It is something like you unzip the file. Previously you zipped the file, compressed the file, now you decompress it or unzip it. And finally, for the formatter, you have a deformatter, or the reverse process of formatting. The relevant information is then sent to the user. As mentioned, we are focusing on formatter herein. So this formatter consists of a sample block, a quantizer block, and an encoder block. Whereas the deformatter consists of, for encode we have a decode here, and for sampler we have a low pass filter. So presently we would look into sampling and its reconstruction by means of low pass filter. So let us revisit some of the advantages of digital communication over an analog communication. First and foremost, we know that the transmitter sends a waveform from a finite set of possible waveforms during a limited time. So what this means is that whatever you're sending, it is either in terms of zeros or ones. So you have a finite set of possible waveforms that would be transmitted. Next, we can use a regenerator receiver. By that, what I mean is that if you have a pulse, say we want to send a bit of value 1, right, and it has plus 5 volt. So we generate plus 5 volt and send transmit it. So at 100 meter from the source, there is some attenuation that you would observe. Say at 200 meter, the attenuation has increased. At 300, the amplitude has considerably reduced. At 400, it is almost approaching 0. So attenuation beyond this point would render the bit useless. So we would not be able to detect the bit, right? So what we do is at this point, or at this distance, we implement a regenerative repeater, and what it does is it reverts back to our original waveform. So it would consider some kind of a threshold over here. So if anything which is above that threshold, it would consider it as 1, and anything which is below that threshold it would consider it as a 0. So that threshold could be at 2.5 volt for an original message of 5 volt. So this is our regenerated pulse. The regenerator then transmits the signal further. Another important advantage of digital communication is that no matter what the data is, actually you're just sending a bit, right? So if you have a data, or if you have a voice, or if you have media, in digital communication we are just dealing with bits, right? So we are just sending bits, zeros and ones. So we don't have to look into other protocols. Some further insights in terms of data and transmission. So if we have an analog data and we are interested in sending it by means of an analog signaling as well, so what we are going to do is we have two alternatives. So we can just send it as is over the air, which is at the baseband. The spectrum content would be at low frequencies, but for that you would need large antennas, because if the frequency is low, or you can use a carrier to modulate the signal on a specific spectrum and make use of small antennas. Similarly, if you have an analog data and you want to send it by means of digital signaling, so what you can do is you can make use of pulse code modulation, right? So by codec we mean coder and decoder. So we can use pulse code modulation, a thing that we would also look into in the forthcoming content, right? So moreover, this allows usage of digital transmission for analog data. So you can send your analog data by means of digital signaling, and as mentioned previously, we have the option of regenerators, so which can recover back the original signal if they are attenuated to some extent. Moreover, any continuous time data which is analog can be stored in DVDs, CDs, USBs by means of digital signaling. So we would need an analog to digital converter, or we would use pulse code modulation. So similarly, we can have a digital data and an analog transmission. So this can be done by means of modem, just a nickname for modulator and a demodulator. Some media such as optical fibers only propagate analog signals, so you would need the conversion from digital to analog as well for this kind of application. Lastly, you can have a digital data and you can send digital signals. Again, you have two alternatives. The first one is that signals consist of two voltage levels, that is plus 5 volt for bit 1 and 0 for bit 0, right? So they can have two values. Or you may use the channel coder previously discussed to induce some useful redundancy in the data. That is, instead of sending 3 bits, you may send 4 bits, but the fourth bit is the parity bit, which would be able to detect the correctness of transmission.